Hello guys, welcome back to the channel Campus Coders. Today we will see some questions about greedy algorithms. So greedy algorithms questions are basically like there will be several factors, okay, and we need to maximize an factor where there will be uh, you know a restriction in other factor. Okay, let's see one question related to that. This is a problem related to fractional knapsack problem. Okay, so given that there are like n items and then the corresponding values will be given. Okay, values are nothing but their worth of each items is given in a array, and then we need to put these items in a knapsack which has capacity of w. Okay, it can take w amount of weight only. Okay, it cannot get anything greater than that. Okay, so we have, for like let's say in this sample input we have three objects, three items, and each of its prices is given and each of its weight is given, and we can take only 50 kgs of that of any items into our nap. Okay, so by this way we are going to solve this problem. And one more thing they have given is we can take the item as a whole or we can break it into smaller units. That means when we have, let's say, a piece of like 30 kg item, we can even take like 20, 25, like a part of it as well. So this is where the fractional knapsack problem arises. Okay, so what we can do is here our ultimate aim is to maximize the values. Okay, the total value obtained should be maximized, so we need to maximize the values, but at the same time we need to, there is a restriction in weight as well, so we need to take care of weight where we have to maximize the values. Okay, so keeping this in mind, what we can do is we can arrange in an order. Okay, let's say increasing order of a value. Okay, because that's the, the thing we need to maximize, right? So we can write it in a table, and what we can do is we will have two variables. Let's say value. Okay, let it be 0 at that time, and weight, that's also 0 initially. Okay, and first item we are going to add. Okay, its weight will be 0 plus 10, 10 now. Okay, 10 is less than 50, the maximum weight, so this can be added, so we are having 10. Okay, and the corresponding value will also be added, that is 60. Okay, and then we are going moving on to second item, its weight is 20, so 10 plus 20 will be 30. Okay, so total weight is 30 right now, and the value is added, so value will be 100. Okay, and then now the weight is 30. We are moving on to third item and weight is 30, so 30 plus 30 will be 60. Okay, which is greater than 50. So this we cannot add it, this item we cannot add it as a whole, we need to make it as a part. So we can add only 20 of that, of the whole 30, right? So we can add only 20 kgs of the whole 30, so we can add corresponding amount of value alone to the knapsack, right? So initially it was 100, now we can write it as 100 plus 120 by 30. This will give a value of each and every piece, right? And then we can add 20 of them, so into 20. And if you do this calculation, we will be getting like 3 4, right? So 8 180 will be getting at this. Just acha, there is a mistake here. Like we are adding 100, right? So 60 plus 100, it will be 160. So 160 plus this fractional part will be getting 240. That's our final answer, right? So this is the way we will be solving fractional knapsack kind of problems, and this will be the code. So we will be first sorting the array, and we will have current weight and then final value, and then we will of course traverse the array, and we will, the first thing we are going to check is the restricted factor, because that's the whole point. We need to, stop wherever necessary. So if current weight plus current weight plus the new weight is less than the maximum value, so we can add that value into that, right? So we are adding the current weight and then final value. If it is not so, we are finding what is the max extra weight we can add. Okay, that extra weight will be made as a, a part of the whole value, and then we are going to add it to the final value, and we are going to return the final value. So this is how this question is done. So next question, this is the, like, we need to find the minimum number of notes to get a particular money. Okay, let's say there are like 1 2 5 10 20 50 100 500 and then 1000 values of notes. Okay, we need to find the minimum number of notes to, make the change. Let's say there is like 121 rupees. We need to get like minimum in how many ways we can get the value of 121. We can either like take 1 rupee coins of 121 1 rupee coins, or you can do in any other any values, right? We need to find the minimum possible thing. So for 121 we can take 100 rupees note and 20 rupees note and 1 rupees coin. This is the minimum possible way to achieve that value, right? So in that way, whatever the values they are giving, we need to find the minimum possible number of coins or notes. Okay. So what can we do is, the approach would be something like, let's say 121, we know the value is 121, and we cannot use any notes which are greater than 121, right? We cannot use 500, we cannot use 1000. So our answer values lies within this range only, right? So we can take the possible ranges. Let's say in this one, if you see, so the, let's say for 49, our value lies with which is less than 50 only. That is from 1 to 20 only our value is going to lie. So for 49, let's say for 49, the maximum rupee note we can use is 20, right? So first note we can use is 20. So our remaining value would be 29. Okay, and then the next again we can use is the 20, we can use another 20 rupees note itself, because still 20 is less than 29, right? Now when we reduce it, it becomes 9. Okay, now we cannot use that 20 rupees note. Okay, so we will go to next possible thing in the array, that is 10. Even 10 we cannot use because 10 is greater than 9. So we'll go to next one, which is 5, and that we can use, and we are going to subtract it again. So 4, we cannot use 5 rupees coin again, so we'll go to the next one, that is 2. So we can use 2. So 4 minus 2, 2. Again 2 we have, so we are going to 2 again. So it becomes 0. Ultimately we need to get it into 0. Whenever we are getting it to 0, we are going to stop, and we are going to count how many coins or notes we got, and that will be our answer. Here it will be 5, right? So in that way we are going to do the problem. So let's see the code. We will have a value, we are going to have an answer array. Later we are going to count the number of arrays, or if they are asking the vector array itself, we are going to return that itself. So these are the possible coins which is given in the question, and we are going to traverse it from the back, right? So from the back we are going to traverse it whenever the value is greater than the coins which we are, only then we are going to have a loop, or else we are just going to move on to next values, so that we are going to eliminate the impossible coins which is not related to this. For example, here if it is 49, 1000 is not going to be anyhow related to this one, so we are not going to go into this while loop itself, which is going to, traverse it backwards. So whenever the value is greater than the coins value, we are going to reduce it and then push it to the answer array, right? In this way we are going to do until we are getting into 0, and then we are going to either return the vector answer or the number of coins, whatever is asked in the question. So that's it for this question.
Okay, another question from greedy algorithm. This question is actually like a base model to understand how greedy algorithm works. So given there is an array, okay, we need to check like the whatever the given in this array, or the maximum number of steps you can jump forward from that element. Okay, So we need to find whether we can reach the last index or not from the first index. Okay. So let's say in this array 23104. So there is a frog in the first index. That means the zeroth index. Okay. So the value at zeroth index is 2. So it means the frog can jump either one step forward or two step forward, maximum two step forwards. Okay. So based on whatever decision it takes, it should finally reach the last index. So that's the, if it is reaching, we are going to return true, or else we are going to return false. That's the method. You can see an example here. It need not to be the maximum jump always, because we don't know what will be the jump max at that element, that index, right? So we cannot always take the best possible case to jump so that we can reach the last index. Here you can see you can jump only one step forward, and then take the maximum in this part so that you can reach the last index. But then if you jump twice here, you cannot reach the last index, right? So we have to see all possible ways and then check if we can find the if we can get into the last index. The same way for this one, here we cannot reach the last index, so we are going to return false. So how we are going to do is, we are going to use the greedy algorithm. The greedy algorithm, it's like ultimately we are going to take the best possible cases in every each step, so that we will ultimately find the optimal, best optimal solution. That's the, way how greedy algorithm works. We can see how this question we are going to code. By that you can understand how it works. Okay. So what we can do is, so we will assign a maximum index, because whatever they have given here is a maximum index, right? Where at each index there is a possibility that it can either jump once or twice, or up to the number of times given in that index. So we don't know what jump we can take, right? So what we will do is, we will assign a maximum index at that point. Okay. And then we will iterate the array. Okay. So what we are doing is, so we are going to check if the current position is possible to be arrived or not. Okay. Ultimately we need to find the, if we can arrive at the last position, right? Before checking if we can arrive at the last position, we will check for each and every index if that index is possible to be arrived or not. Okay. So if it is like not possible to arrive at one position, then it means we cannot further move at all, right? So we will check positive, like one by one, and then ultimately we will find if we can reach the last position or not. So that we will do by adding this part of code. Okay. So we will see how this works for an example array, so that you can understand how this works. So let's take this array 23104. So at first the frog will be at zero position, so we need to take some things, right? So zero is greater than zero, it's not true. So of course, because it's there in the first position already, so we are going to, in change the max position now. Max position will be changed accordingly to the previous previous max position, when compared to the maximum jump it can take from that position. Okay. So here we can say the previous max position is 0. Okay, max index is 0. The now the maximum jump it can take is 0 plus 2. Okay, why we are adding 0 plus 2, that I will say you later, as progressing you can understand. So 0 plus 2, that is 2, right? So it can take maximum of 2 jumps from that position, so we are increment changing the max index to 2 for now. Okay. So now the max index is 2. Okay, now if we go on in this loop, now I value will be 1. Now 1 is uh, less than greater than 2, which is false. So what does this mean is, if the I is less than the max index, or yeah, when I is less than max index, it means the position I is possible to, get possible to arrive by the frog. That means, since the max index is already 2, so it means the frog can reach position 1, position 0, right? Because the maximum is 2, it can reach any positions below less than 2 or equal to 2. So 1 is possible to arrive. So this is true, so we can remove this case at this position, and we can change the max index. So here the max index would be maximum of max index. Now the max index is 2. Okay, that means it can reach maximum of index 2 for now. Since it is already in the position 2, we can see what is the, sorry, position 1 now. So we can see what is the maximum jump it can take from the position 1 now. Okay, so maximum position it can take from the position 1 is, it's already in the position 1, so 1 plus the maximum jump it can take from here, 3. So 1 plus 3, that is 4. So 2 comma 4 is the thing we need to compare right now. So while comparing this, this is the maximum, so it can, the max index is changed to 4. You can understand now, I guess. So we are going to check the, we are going to change, modify the max index in every loop by comparing the max index at that point plus the maximum jump it can take at that loop. Okay, so at that loop the maximum jump would be the index value plus the value at that index, so that will be our maximum jump from that point. Okay, so from this we can say 4 is the maximum, so we can change the max index to 4. Okay, so now I value will be 2 now, so 2 is of course less than 4. So since 4 is already max element, we can of course get into position 2, so that's not a problem. And then max index now it will be 4 comma, here it will be 2 plus 1 3, so it's already 4. If we just go on through this loop, we can say that we ultimately we can reach 4, or you can just say like already the max index is 4, the last index is also 4. Okay, so it means that we have already reached the last index, right? So we can just add another if statement, like if max index is equal to length minus 1. Okay, so if it is so, we can return true at that point itself, or time itself. It's not going to cause much of time complexity, but yeah. So now this is how this question works. You can see a sample working here for like a point where it doesn't reach the final index. So this is like a simple problem. So this problem can be, further added on question, like we need to return the minimum number of jumps to reach the final portion. So now here it, there's where it gets, things get interesting. So let's take the same thing itself. Okay, same example case. So what we were previously doing is, we were doing the maximum jump at each case, right? So the same thing we will update in the array itself. Okay, at each index we will update the maximum possible jump it, maximum possible index it can reach, and we will do it here. Okay, it's like more or less similar to prefix array, but it's not prefix array, you can understand, right? Prefix array means you are just going to add the previous elements, and then you are just going to make an array. This is not prefix array according to the question how we did before. We are going to do it like, first the frog will be there in the first position, so first position will be the same, so we are just going to do the changes from position 1, right? So at position, what we are going to do is, we are going to compare the previous position, that is 2. Why we are comparing the previous position is, the previous position contains the maximum position it can jump from the thing, right? From that position, right? It means it's like the max position what we were doing here, max index what we are doing here. So 2 comma, the maximum jump it can take from this point. So here it can take maximum jump is, the index is 1, so 1 plus 3, that is 4. Okay, so 2 comma 4, the maximum is 4. So at this position the maximum index it can go to is 4. Okay, so if we go here, it for I is equal to 2. Okay, for I is equal to 2, we can compare 4, the previous position, it has 4, right? We are not going to check here, we were already changing the elements. So now the the value at num nums of I 1 is 4, right? Because at position 1 we have already calculated that the maximum position it can go is 4. So this is right now the max index kind of thing which we were doing. So max index is 4 right now, and then we are going to check what is the maximum position it can go from the position uh, index 2. Okay, that will be 1 plus 2, index is 2, right? So 1 plus 2 3. So by maximum doing maximum of this one, we can get the maximum is 4. So here it is 4 again. While I is equal to 3, we are going to check for a maximum of 4 comma 0 plus 3, that is 3. Again the maximum is 4 here, and then for I is equal to 4, we are going to compare this 4 4 comma this 4 plus index 4, that is 8. So maximum is 8. Okay, so we got this array right now. This is the modified nums. Okay, this is the modified nums we have got. So we now what we are going to do is we are going to have an index that is going to check if we are going to reach the final index or not, and then we are going to have an answer. That means like what is the jump we are going to have. This one we are going to increment in every loop. Okay, so while index is less than the final index, okay, the last index, we are going to increment the jump value, and then we are going to assign the index to the whatever the maximum jump it can take at that point. Okay, so let's take this example. So initially answer is 0. Okay, answer is 0. That means the jump value is 0. Now in the index is also 0. At index 0 what we have is 2, so the maximum jump it can take is 2. So the index now the frog jumped to index 2, right? So the frog jumped to index 2. So since it jumped to index 2, we are going to increment the jump value to 1. So again now 2 is less than the max last index, that is 4, right? Last index is 4. So since 2 is less than 4, what now we are going to increment the jump value to 2. Now it's going to jump, right? So what index it is going to jump? We are going to jump to in 0 1 2. This is the value at index 2, that is 4. So it is going to jump to index 4. Okay, and then now 4 is less than index last element. No, it is equal, so that it means it has reached the final element, right? The final index. So we are going to return the whatever the jump value we are having, it is 2. So we are going to return that as the answer. So that's how this part of thing works. We can see a simple a brief explanation of what how this is working. The first loop modifies the num side to all the maximum index we can go from single jump from I. That means this loop, whatever we are having, what did it mean is it modifies the nums I to hold the maximum index we can go up to in a single jump from I. That means from the position we are calculating the maximum position it can jump. Okay, from index 0, it maximum position it can jump. What is the position that we are going to modify in this array? So that's what we are doing in this array, in this loop. The second one is, since the nums I minus 1, the last element already contains the maximum, we can reach up to I minus 1. So that this is the maximum index we are going to you know find, right? So for the ith element we can go further if the nums plus I is greater than the modified nums I minus 1. This is what we were doing, the maximum part, right? We were comparing the maximum position it can jump from that index, or the what is the maximum jump it were like having in the previous position. We were comparing these two, and then we are going to just accumulate the count of these maximate jumps. Okay, so this is how this code works. Okay, last question of this video. So there are like two arrays given here: the arrival and departure time of a train, of the trains. Okay, we need to find the minimum number of platforms we need at the railway station so that no train has to wait. Okay, so let's take an example to understand this question. So in this example, let's say it defaultly we need one train to come uh, for using the train side. So there is one platform at 9 o'clock. One train comes, okay, and then at 9:20 it leaves. Okay, so this leaves at 9:20, and then at 9:45 there is one train coming. You can use the same thing. Okay, and then it leaves at 12, but before that there is another train that's coming at 9:55. We This train cannot just wait till 12 for this train to leave, right? So we are having another platform at 9:55. This train comes, and then this leaves at 11:30 only. So since this leaves at 12, this leaves at 11:30, but before these two there is one more train that's coming at 11, right? So this cannot wait, so we have to have another platform for that train. So this comes at 11, and then by 11:30 this leaves, to 11:50 this leaves, 11 12 o'clock this leaves, right? So after seeing these things, we can see at 15 there is another train coming. You can use any platforms here. You can take this platform at 15, it comes, it leaves at 19, but before 19 there is one more train that's coming at 18. So we can use another platform, this 18, and then at 19 this leaves, at 20 this leaves. So we need minimum of three platforms for this thing, right? The same way we need to find for any number of arrays they are giving. So one way of doing it is, first sorting arrival and departure times. Okay, I have sorted the departure times like this. We can compare the arrival of next train with the departure of previous train. If there is any clashing, it means we need one more platform, right? Here let's say 9:45, 9:20, it means the previous train is going to depart before the arrival of coming train, so we need not to increment any platform, so we can just use the same platform itself. But here if you see 9:55, 11:30, it means we need one more platform for accommodating the upcoming train, right? So at that time we can have another thing, right? So if you see here we need only one platform, so here the count value becomes 1. Okay, here if you see in this part of thing, we need a maximum of 3, right? So we will have a count of value of 3 here. So count 1, count 3. So if we are going to have the maximum of this 2, and then we are going to see uh, 3 is the maximum possible at this point of time, right? So by this way we are going to find. So if you see, we are having base of one platform at that time, and then we are having I is equal to 1 and j is equal to 0, because we are going to compare arrival of upcoming train with the departure of previous train. So we are having 1 ahead of I. Okay, if arrival is less than departure, we are going to increment the platform count and then increment the I value. If it is not so, we are going to decrement the count value and then increment the j value, j pointer. Okay, and then we are going to update the value with the current maximum number of platforms. So this is how this question works.
For today's video. I hope you have learned a lot of things in this video. The links to the questions will be given in the description below. You can definitely check it out and practice them. You can follow me in LinkedIn and Instagram. The link will be given in the description below. So yeah, I will meet you in the next video. Until then, keep coding. Bye bye.